So in part B here, you'll probably start to understand a little bit more my reasoning in making up my Willy game, because we're going to start talking about the Wonka, right? Willy Wonka and all that, right? So the idea is that if two hands, and it's very easy because we've seen multiple combinations of cards can give you the same Willy value. So if two players have the same value for their Willy of their hand, how do you decide who's the winner? So that is where we're going to compare then next the Wonka values of the two hands, right? And as it says here, the Wonka, okay, is the actual face value of the highest card in the hand, right? So we have to do some extra logic. So we'll have a new property, okay? We'll do it in the same line that we did the Willy, where it was just a getter, right? A read-only property returning that value. Well, we'll do something as well for the Wonka, right? Now, I've asked you to do it in a separate class file here. The only reason for that, I mean, truth is, it would be no harm or foul in just adding this new Wonka property right in the same class file. But I have found that even though people, they talk to you about partial classes, everyone nods their head, and you go to actually use it, and they don't seem to quite understand. So I want to do an example where we actually have a chance to actually put a partial class into use here, right? So we want to add a new property to Willy Hand called Wonka, but I don't want to do it in the same class file. So that's basically what this comes down to. So if I go back to my project now, hang on a sec, right? At the moment we have our Willy Hand class, okay, right here, public partial class Willy Hand. I specified partial. We aren't really using it as a partial class at this point yet. But what we want to show then is if I were to right click and add a new class altogether, or I should say a new class file, right? I'm going to call it, I don't know, more Willy Hand. Now, that's just the name of the file, right? That's not going to be the actual name of the class. But what I'm going to do is I'm going to actually take this here and copy and paste over here. So really what I'm doing is I'm making use of the fact that we have partial class support in C#, which allows me in this totally separate class file, right, to continue adding to Willy Hand, right? Now, really neat thing about this is as I work in the code here, I'm going to find that I have full access to all of the properties, these private ones, public properties and so on. I have access to everything. It's just as if I'm writing it inside this spot, right? But because I'm doing it in a separate class file, even though I am doing so because it's a partial class, I have full access to all the properties, private ones as well, that are inside Willy Hand itself, right? So what am I going to do here? Well, I'm going to create my Wonka property. Okay, I'm going to do it pretty much exactly the same way as we did for Willy. It'll just be a public int, right? It just returns the highest value of any individual card in the hand, right? It's a good thing that when we saved the cards, we didn't try to change their value. We only do that substitution of 10 for a face card when we're calculating the Willy, but the card itself is stored as its full value. So that allows me to do code. And this is very similar to a simple example we did before, I think. But I think that this should do it, right? If I go like this, if I compare the cards and find that one is bigger than the other, then I return that one, else I return the other, right? I think that it should work. But you know what? Unit tests will confirm and make sure that I actually am correct in the logic that I've put in this code, right? Okay, so again, the purpose of using the partial class is just to drive home the fact that, hey, I can continue basically writing properties, methods, whatever, of a class in a separate class file, right? And notice though, that look at this, I'm accessing the values of card 1 and card 2, which technically are private inside Willy Hand. But it's okay, because even though I'm over here, I'm in the same class. All right, I'll shut up. I've repeated myself too many times. There we go. But there's our additional property. Our Wonka property is now available. So if I come back to my test class, maybe the first question is, well, gee, do I do a new test class in order to start testing the Wonka property? No, because it's still part of Willy Hand, right? It's just a new property in Willy Hand. So what I'll probably do here is I'll actually add a new region as well, right? For the next group of tests. Okay, a region for exercise 2, part B, right? And I can just start putting my tests in. So one of the things that's a little different about this situation now is really we have two, right? Our unit tests instructions here call for tests for both the Willie value and the Wonka value based on essentially the exact same use case, right? So case B1 is a 7 jack, okay? So for that same arrangement, we're going to do two separate tests. Now, how do we go about doing that? Okay, interesting question because, really, technically speaking, uh, there's one of the rules of unit testing is you should have a single assert in every test. At least that's what some people would tell you, right? Not everyone totally agrees with that. It has to be a hard and fast rule, but some people strongly believe in that tenet. Now, it is true that different tools have different approaches that allow you, in some cases, very elegantly to create one arrangement and do multiple tests on that arrangement. But let's just have this good discussion because just even with the simple approach available right here without doing anything extra inside of our MS test environment, what might we end up having it look like, right? Well, here is my B1, okay, exercise 2, use case B1, where we have our 7 and our jack. Now, I know I really want to check both that the Willie is 17 and the Wonk is 11, okay? So here I've got my 7, my 11, I create my Willie hand, right? And my expected Willie is 16, and my expected Wonka is 11, right? Hang on one second. Let me just back this up a little bit here. Okay, this is what it would look like if I was just doing a test on the Willie, right? So I just have all my arrangement in place, my expected Willie, I get my actual value, and then I check if they're equal, the expected Willie and the actual Willie, bada bing, bada boom, right? So that would be one approach, and then I could just copy paste the whole thing and do the test for Wonka, right? But the lazy programmer in me would right away be saying, wait a second, you've got all the exact same code in the arrange, right? Can't we check both the Willie and the Wonka in one test? Some people would say no, but some of us are willing to commit a small sin once in a while to get the job done a little bit more efficiently. So what might it look like if we try to do both together, right? Okay, so obviously then I would need to have my expected Wonka in place as part of the arrangement, as well as the expected Willie, okay? And then I would have my actual Wonka, and for that, of course, I go to the target, just like I did for the Willie, and get the Wonka value, right? And then finally, I would have both, count them, two assert are equals inside the one test, right? One for the expected Willie compared to the actual Willie, the expected Wonka compared to the actual Wonka. Now, let me defend this approach for a second, right? If this passes, then everything is good. Both of our Willie and our Wonka values pass their tests, right? So as long as everything passes, no one can really point at this and say, ooh, there's a problem, right? How do I know which has failed, the Willie or the Wonka, right? If they do fail, yes, that's a valid point, right? I would have to go and do some further examination to try and figure out how on earth would I actually know, was it the Willie or the Wonka? Do I set a break point and step through, et cetera, right, in order to find out which is violating its test, okay? So I'm just going to share one last thought here. What we can do is we can add another parameter here to our R equal, gives us a chance to actually give a message to report, okay, if a assert fails, right? There we go. So right now, of course, this should fail. The test should fail in case you didn't notice. Remember, we should get 17 for the Willie. Anyway, all right, well, let's just see if we can tell when I run this test. Did it pass? Did it fail? And if it failed, why, right? Okay, so you see the 14 previous tests passed, one failed, right? So let's go down, we'll have a look at it in particular, right? And here we go, here's the message. Assert R equal failed, expected 16, actual 17, Willie value not equal, right? So there you go, so there's that message. So now it's not so bad. I do know exactly which one is the problem, right? It's safe in that I can't pass the test if anything inside it fails, right? In order to pass, everything must be good. So let's just, I'm going to do a rerun of failed tests. and now it passed. Okay. So yes, we do have a valid test, and I think that this is a reasonable approach. We're sharing the common arrangement. Okay. We are testing multiple asserts here, but we do have full and clear messages to let us know which one has actually failed. So it's up to you. You know, some people really swear, no, 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 you can only have a single assert in any test. And I'm not going to get on a high pulpit and try and tell them any different, but that is something just to share with you. It's food for thought. Uh, it's that if you got hired and the company you work at says, no, we only have one assert, then you have to just write a whole bunch more tests or use a tool that gives you the ability to uh, loop through multiple tests for the same arrangement. Okay, let's go on now to the next bit. Okay, so I just put in the last three of the use cases specified in Part B here on exercise 2. So, things like King Jack, right? So we know that the Willie would be 20, the expected Wonka would be 13 because the highest card is a King, which is 13, et cetera, et cetera. So that's just satisfying the requirement to have all of our use cases covered then. And I'll just do a final quick test of everything and make sure that everything is passing and whoo, we're good. We have all these tests. You can quickly see how after a while you get so many tests that you want to start organizing them in playlists or groups or something like that. All right, so that's good for now. Let's go on to the final part of exercise 2. So I'll just bring up the instructions again. So in part C, okay, all right, so we have our Willie. We've added the Wonka so we can determine if there's a tie in the Willie, okay, which the two hands passes or wins by the Wonka value, et cetera, right? So what we need now is we're going to add an actual new class this time, not just a partial class, but a new class called Willie Winner, right? And the idea here is we're going to have a method that we pass in count them, two Willie hand objects. And the purpose of this class is to do the logic to determine, well, which of the two hands is the actual winner? Is the first hand? Is the second hand? Or once again, it's quite possible that you can tie, even though you're comparing both the Willie first and then the Winnie, right? Okay, so that's what we have to do. We have to make a class for that, and you'll have to write it yourself, right? And then create your unit tests. So I'm going to just look at the tests. I'm not going to share my class with you. Well, maybe I will. I don't know. I haven't quite decided yet. We'll see how it goes. Okay, so I came to Willie Game itself over here in the Solution Explorer. I added this new class, so now we see three. We have more Willie Hand, which was just an extension basically of the Willie Hand partial class. So now I have my Willie Winner class, right? So unlike Willie Hand, remember Willie Hand, we assigned it as a kind of regular class. You instantiate it, it remembers its value so that we can keep it in memory, pass it around from one method to another, and it restores all of its information. The task of our Willie Winner class here really is just to determine which of two classes is the winner. When it's done its job, it's done. So it makes much more sense to me that in this case, we would do it as a static, right? So do it as a static class Willie Winner. I might have a static method here. I don't know, win. That's the only thing I could think of. Win, winner, something like that, right? And it's going to actually return the integer value depending on whether hand one or hand two is the winner or if it's a tie. Remember, our instructions gave that. They said return the integer value 1 if the first hand beats the second, -1 if the second beats the first, and 0 if they're tied. Now, maybe there's other approaches we could have done, but that's what our instructions tell us to do. So we'll follow that and we'll return an integer value, right? Okay, and then as it notes here, when we compare hands, we compare the Willie values first, right? And the highest Willie wins. Bada bing, that's it, you're done. If the Willie values are tied, then we compare the Wonka values. And then in that case, whichever has the higher Wonka value, that hand is the winner, right? Finally, of course, if they are tied both first on the Willie, then on the Wonka, then we do simply call a tie and we return 0, right, if they're tied, right? And we can see here some use cases. Now these use cases, in this case, we actually have to build actual Willie hand objects, one for hand 1, one for hand 2, that we then pass as the parameters to our Willie Winner static, right? Okay, so that's good enough. Let's get back to it in Visual Studio, right? So I don't know, maybe I will throw the code in here after all. even though you should figure this out on your own, right? Because there's more than one right way to do it, okay? But my simple logic is this. Okay, we start with hand one. We do that general thing. We'll assume to begin with. So if hand one's Willie is bigger than hand two Willie, we're done, right? We found that hand one beats hand two because we compare Willies first. So we return one, okay? Else, if hand one Willie is less than hand two Willie, then clearly it has lost. So we return minus one, lost in terms of hand one compared to hand two, right? So the third case is they're tied, at least in terms of the Willie value are tied. So that's just a simple else then, right? Because we'll jump out of execution either because hand one won or hand one lost compared to hand two, and else is that they're tied. So then we start comparing Wonka, and the same basic logic works fine, right? If hand one Wonka, okay, beats hand two's Wonka, then we return one. If it's the opposite way, we return minus one. And then the else is that, hey, guess what? We got here because both the Willie values were the same and the Wonka values were the same, right? And just note that's not impossible to happen. In fact, as you'll see here in our instructions, like a Jack 10 and a 10 Jack, right? They're definitely equal, okay? Um, even actually like a Jack 10 and 10 Queen, right? No, that wouldn't be equal. Sorry. But you can have a tie on both. Okay. Forget what I said there a second ago. Brain fart. All right. There we go. So I think that this is valid, but we do need some new tests now. Now, do we come back to our Willy Hand test class? No, because we're testing a different class. We're testing the Willy Winner class, right? So once more, we right click and we say create unit test. It's smart enough to realize, oh, we don't need a whole new project or anything. It just added a new Willy Winner test class, right? So here we go. So now we're ready to start working in here. Now, probably I don't really need to define a region because we only have one last set of tests. But, planning ahead for the future, we might add more tests in here later on, as we've seen can happen. And besides, it does give a bit of a self-documenting aspect to using these regions as well. All right. So what I'm going to do next then is we're going to actually start building a arrangement, right, so that we can actually do Willy Winner tests. Okay, so I'm in exercise 2, use case C1, where we have a ace king versus a jack 7. We're going to compare those two Willy hands, and the winner value we should expect is -1, right? And that that is what the expected result of who is the winner should be. Okay. All right. So in terms of arrange, act, and assert, what are we going to do? Well, essentially, the arrange it's pretty straightforward, right? What we need are two Willy hands. So I instantiate Willy hand 1 and hand 2, right? They're both new Willy hands, and I pass in the appropriate values, right? Our ace king and our jack, which is of course 11 and 7. Okay. Now, one more thing that's part of the arrange is we define our expected value. Okay. So we expect -1, right? Because the second hand should be the winner here. Okay. Now, what do we do next? Well, we can just act. Okay. So we call Willy winner and the win method, and we pass hand 1 and hand 2, right? And that will give us our actual, right? So we have our expected value and actual value. So finally, we can just assert, and we can just use a plain assert r equal. Okay. We expected the one integer value, the actual one was returned by Willy winner and the win method. Notice we don't have to instantiate Willy winner, right? Because remember, it is a static class. Okay, so let's just carry on. Let's actually go ahead and run this test. And then you see now we have Willy winner tests, right, in addition, and our test C1 passed, okay? So it was correct in determining which one was the appropriate winner according to our instructions. So, I'm not going to make you watch me put all the others in place. Maybe we'll play around with the last one a little bit just because it's the most interesting. Hang on. Boy, I don't know who wrote up these use cases. Oh, wait, I think that was me. Okay. All right. So we did the first use case here and that was basically the second hand was the winner. It's worth just thinking for a second. Why is that the winner? Well, think about it. Ace King, that's going to be a Willie of 11. Jack 7 is a Willie of 17. So there you go. So right on the Willie value alone, the second one is going to be the winner. Let's look at the next one. Okay. Ace King, that's 11. 6 and 4, that's 10. Oop, there you go. So the hand 1 will be the winner just based on Willie, right? Coming down to the third one, Ace King is 11 again. Queen Ace is once more winner. So we'll have a tie. We'll have a tie for the Willie value. So then we'll have to compare the Wonkas. So the biggest card here is a king. The biggest card there is a queen. So the first one will be the winner, and that's what we expect, right? So yeah, you can just think it through. But it's good to have it done in use cases to make sure that we're actually doing it right, okay? Number 4, here we could just say, okay, a 6 and a 5. Well, that's, pardon me, that's 11. Ace and a king is 11, right? But of course, the king is a much higher card than the highest card in this hand. So the second one will be the winner based on the Wonka value, and so on. So here's now anyone might look at this and say, well, of course he's going to be overall winner. All you're doing is switching the cards in your hand, which one you got first and which one you got second, right? So it's not a very fair test, although it does determine it is going to be a winner. Let's do one more. We'll make up one ourselves here, and we'll just put that in place. Something that's a bit more fair of a test, perhaps, right? I'll just put it in place and we can talk about it. So what I thought of here for an extra case is a king and a 10 and a queen and a king, right? And I'm thinking the winner should be a 0, right? Example of a tie with hands that are not a mirror image of each other, okay? Now think about it, a king and a 10, well, that will be a Willie of 20. A queen and a king, that will be a Willie of 20. So it'll tie on that first test, the Willie test. Then you go to the Wonka, the highest card in both hands. Well, it's a king here and a king there, right? King here, king there. So it'll tie on the Wonka as well as it tied on the Willie. So overall, we should expect a tie, right? And that's it. So that just finishes our little exercise. I'm just going to click to run all tests. And there we go. So we have all of our tests running, all of our Willie hand tests, and then all of our Willie winner tests as well. But, hopefully you'll think of this example as a reasonable discussion of, how we can put unit testing together. And you can see that it can be very boring. I mean, it can be very repetitive types of programming, but it is just so important. It's worth the effort to do some sort of validation that your code is actually working properly. So the later on, if somebody comes here and makes a change to your class, boom, right? Your unit test will catch it if it does anything invalid and invalidates the proper passing of all the earlier tests that are in the system. That's it.